And now I'm going to turn it over to Ena, who will be speaking to us about a really microservice. That's a great name, Ena.
Thank you. I am Ena Urbach. I'm an independent developer in Seattle, Washington, doing business as Custom Databases of Seattle. And I'm going to talk about a really minimal microservice that I put together to enable Claris FileMaker database to match records that have text fields that are nearly matching, but not identical. First, I'll do just a little intro about me, since I don't know a bunch of people, and so you don't know me either. I'm a molecular microbial ecologist by training. I used molecular microbiology techniques to study wild populations of microorganisms in oceans and lakes and in soils. And I did my diligence as an academic scientist before moving over to work in a biotech company, where I used my molecular biology methods to try to discover new antibiotics for soil bacteria, new antibiotics from soil bacteria. And as part of this, I started building FileMaker databases to keep track of samples and clone libraries and to run the business. And time passed, other things happened. I moved to Seattle and started Custom Databases of Seattle in 2015. And I haven't looked back. I've, over the years, hopscotched across the country. Here are places I've lived with the text scaled according to how long it's been since I've lived there. And because we're allowed to have a little fun, I've also scaled this list according to how much I've enjoyed living in these places. And apologies to people in Knoxville, Tennessee. I'm going to talk about what microservices are, why as FileMaker developers we might find them useful, and then talk about my particular excuse for learning to build a microservice, and I'll run through some things that will allow you to learn to build a microservice and run it, and I will then submit myself to the wrath of the demo gods. What I'm trying to give people as takeaways really are a sense of empowerment that you can do this. I want to paraphrase Tyler Tullock, who might or might not be on this call. But he would always say, when he was presenting some particularly cool thing he'd done with his FileMaker database, he'd say, "I'm just a musician. If I can do this, you can do this. So I'm just a microbiologist. If I can do this, you can do this." And I will give you a set of minimal set of tools, which are in the chat and also in the Slack channel, that will allow you to learn to build your own microservice. And one of the links allows you to download code to do the exact same thing that I've done. Microservices, they are small, little tiny web servers that listen for REST requests, and respond using a small number of functions in their coding. Microservices are the atomic components of service-oriented architecture, which is a web application architecture that calls out to different microservices to perform different components of a larger set of functions. So if you set up a microservice, you will be allowed to use very important sounding buzzwords listed here. I also need to point out that microservices can be programmed using pretty much all the programming languages that are out there. The one that I have some facility with from doing web viewer stuff in FileMaker and a little bit of website stuff is JavaScript. So the stuff I'm going to present will be in JavaScript, but know that you can use lots of different languages. In the FileMaker context, most of you all of you who are FileMaker developers know that there are some complex calculations that are really slow, or maybe perhaps impossible, using FileMaker's calculations and script engine. And there is a wide world of software developers, even beyond Claris. And if you can leverage the large number of open source free libraries that are out there to solve FileMaker problems, you have really enriched the variety of things that you can do in FileMaker. You already know how to use curl and insert from URL to send queries and receive answers from web services that are out there in the world. Well, you can write your own web services, so you're not at the mercy of someone else having put some service online somewhere that is exactly what you need. You can put together something that will fulfill your requirements. Also, if you set up a microservice, which doesn't use a whole lot of computing power, on the same computer that you have FileMaker service running on, you can use this technique to do REST requests to your local server without ever sending your data as parameters out into the wide world, which, even if you're using SSL, exposes you to some level of risk. Okay, so my motivation in putting together a web service is fuzzy string matching. And here's Tuppence. She's fuzzy. I just couldn't resist putting my dog's picture up here. Fuzzy string matching. One of my clients is a commercial real estate broker, and he wants to be able to identify properties that are adjacent to each other and are owned by the same business. So here is a mock-up of a layout from his database showing a list view with a web viewer that has a JavaScript enabled map integration. Now, I didn't do this all on my own. I found a dedicated web GIS expert to help me, and this uses Mapbox GIS mapping platform and is way cool. So here we have a couple of properties outlined in the map that are owned by businesses that have almost the same name, but not quite. FileMaker would allow you could use the relationship diagram and link owner businesses that had identical names, but you have a much harder time linking businesses that have nearly identical names, which may in fact be the same business, as similar to what's shown here. So the reason that my client is interested in this is that a couple of adjacent properties like these owned by the same person is potentially the site for a much larger building project than would be possible on either property alone. So I knew from looking at the Claris FileMaker community that there is this thing called a microservice. And some of the really big gun boosters on the Claris community, like Wim de Kort at Soliant and Mike Berge at Mainspring, will every once in a while suggest, when someone has posted some difficult problem requiring intricate calculations in FileMaker, that really what you ought to do is make a microservice to provide these calculations. And now you could argue that you have a little bit less reason to do this, because now we have a script step that's perform JavaScript in WebViewer, but potentially using a microservice is less complicated, because to perform JavaScript in WebViewer, you need to embed your JavaScript in HTML and use the window object in the document object model. And it's potentially considerably simpler to do this in a microservice. Really, my aim was to make it as simple as possible. The suggested methodologies, if you Google around and try and see what is Wim de Kort suggesting and Mike Berge, each of them is using pretty complicated systems. Wim says you should use a PM2 process manager, and Mike Berge suggests using an AWS Lambda server and markdown language. And I don't have any existing capabilities in using these tools. And really, I just wanted to find the simplest way to get my fuzzy matching working. So I came up with a small collection of software tools that I'm sharing with you. The most useful thing that I found is a combination code editor and terminal for running the code, which is called Visual Studio Code. And you can download it for free on the using link that I've provided. Within Visual Studio Code, Node.js, you can run Node.js, which is a JavaScript runtime software. So it runs on a server and doesn't require a browser. So you don't need to encapsulate your JavaScript in any kind of HTML code. You can just run it on Node.js. Part of Node.js is a Node package manager, which is a command line application that allows you to access all of those open source packages that I was talking about. And one of those packages is a thing called Express, which is a very minimal web framework for Node.js that allows you to expose your JavaScript code as a web service. So it's the actual web server. And Express is so minimal, it doesn't even have an icon like I was able to find for the rest of these guys. In my demo, I'll be using Postman, which I'm hoping a number of you guys have used. It's a desktop program that allows you to send REST requests, GET and POST requests, and test whether your requests are properly formed and see what response you get back without having to troubleshoot within the context of FileMaker, so you can separate out your REST problems from your FileMaker problems. Also, in the end, I'm going to show you how to use Task Scheduler to make sure that your microservice is always up and running. So anyway, the collection of references include the documentation for Node.js, Google, and a set of really terrific tutorials by a guy named David Gray. And the way that I managed to put together all of this stuff that I'm showing you is basically by circling around through Node.js and doing Google searches, looking for model JavaScript code out on the web, and watching Node.js for Beginners, which I can't recommend enough. He's great. So getting more to the meat of what I'm trying to do is fuzzy matching. Fuzzy matching is a way of is a overarching name for calculating distances between strings. So strings basically mean text objects, and you are comparing, say, a pair of strings, and you want to ask the question, how different are they from each other? If they were just repeats of the same string, their difference would be 0. If they have some small number of differences, they have a small distance. And if they're really different from each other, they have large distances. So the particular metric that I ended up using was one that my client, who also thinks about these things, thought was a good one, and also is one of the most popular methods. It's called longest common substring distance, and it matches two strings, allowing only insertions and deletions. So the distance between these two strings here is 2. Here is the longest common substring, which is A, C, D, E. And you get there by deleting the B from the first string and deleting the F from the second string. So its LCS dist is 2. I learned about longest common substring distance actually, and fuzzy string matching in general, in looking at DNA sequences and comparing sequences to deduce the phylogenetic trees that map evolutionary distances among microorganisms. So I am showing a pair of DNA sequences to illustrate a example in which LCS dist is 4. So moving ahead to what exactly I wanted to do was I wanted to compare a string to an array of strings. That is one name, say, in a FileMaker record, to an array of different names in other records that could potentially be matches. And I want to calculate the LCS dist between each member of this array and the comparison string, and decide what the LCS dist for each of them is, and determine what the minimum LCS dis sub min is for this comparison string and the array, and then make a list of what members of the array are that minimal distance. So in this example, George Wilson has two potential matches, George Watson and George Watson. So moving ahead to the idea of a FileMaker script loop, I'm showing a little bit of a relationship diagram here with a business table occurrence matched to another table occurrence from the same table, in which the first 5 letters of the business name match. And you might notice that it's more than 14. I only included things that were longer than 14 because the fuzzy matching doesn't work really well if you have very short strings. Anyway, in this FileMaker script loop, for each business, I want to construct a JSON to use as the data component of a curl post request to ask what is the match for a comparison of a name from business to an array of names from this other matching business table occurrence. So I want to create a JSON object like this, and then receive a result that should look something like this. Okay, so I am not going to use my original set of slides in which I was going to go into a deep dive into the specific JavaScript code that I wrote to calculate LCS dist, because people's eyes would glaze over, and it's not going towards that empowerment thing that I'm really trying to get to. So I'll say that for simplicity, I actually just incorporated a JavaScript code into my web service, my microservice, but I could have used an NPM library. And I'm going to show you the, no, not that window. I'm going to show you the sorts of things that you can look for. First, I'm showing the GitHub page where you can download my code. But here on NPM, where you can download the Node Package Manager, and it will, every time you hit NPM, it changes what NPM stands for, which I think is kind of fun. And there are, let's see, what's a good example? Text to speech. No, speech to text. So 597 packages are available to do a speech to text calculation, which you could incorporate into your FileMaker database. So everything on the NPM site is free, and there are lots of, if you do searches for particular ones, here, let's just look at this one. there very frequently is really good explanation about how to use these provided by the people who put it up. And you can do, oh, that was cool. You can do searches on the web and find people who have made use of these things. It's really just a marvelous community. So I encourage you to think about using some of these open source NPM libraries. There are 2.5 million packages. Unbelievable. 54.7 billion downloads in the last week. It's really, really awesome. Anyway, back to this particular implementation. Here I am zooming past all of the stuff about LCS dist. You will see some of these calculations when I do the demo here. Dun, 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 and do demo. So in order to do this, I suggest you install Visual Studio Code, which is open free download. And I'm going to demonstrate here. Here's the zip file from my GitHub page that I showed you. And I've unzipped it. And now I'm going to open it in Visual Studio Code. Download.
You can also drag the file from your folder.
Yeah, I think that you could do that. I haven't quite tried that before, but it ought to work. So here you can see that we have an explorer that mimics the file structure here. And all of this, this organization is something that I learned from David Gray, and it has the meat of the calculations are in a controller. Here is my JavaScript to calculate the longest common subsequence. And it also includes things like an error handler and event logger that allows you to keep track of REST requests and how successful they've been. Also, when the first time that you download the package, you will need to run an npm for Node Package Manager install, which will take the data in the package.json file and use that as a way of bringing down all of the node modules that are called for in the JavaScript. Then, let's see, where shall I go? So here's the terminal. It's running just like you would if you were on a Mac and you opened up Xterm or a terminal. And if we say, one of the important things here in the server.javascript, it's telling Express that you want to use the environment port or 3500. There are a few other ports that you can use on your machine. If you type into your terminal npm start, it will tell you that you have a node server. It's running on port 3500. So you have a little web server running on your desktop now, and its address is localhost:3500. The roots specify that your post request will use a /LCS at the end of the address. And I apologize for going through this extraordinarily quickly, because really all of this is available inside the David Gray tutorials. So when we post, we will be calling the LCS controller and doing these longest common subsequence calculations. And I will demonstrate using Postman. Postman, it looked like a lot of people have at least heard of it. Postman is a way, as I think I've said earlier, a way of testing your REST requests in isolation away from FileMaker. And here I have a JSON array that I'm going to use in REST request. These are business names that are actually publicly available from King County, Washington. These are King County, Washington businesses, and they're also included in the FileMaker database, sample database that you can download from GitHub. Anyway, so I'm going to send a post request to localhost 3500/LCS, comparing this Rangarajan business name to this array of business names, and there, it worked. You received an answer that says Rangarajan Ra. This last entry here is the best match to Rangarajan, and the LCS distance minimum for this comparison is 3. Also, the server has listed that there was a post request to the /LCS endpoint without an error. Cool. Now, in the downloads, there is a FileMaker file that is zipped, and I'm going to open it. And there are 17 records. Businesses all have those same names, in fact, as this comparison here. And here is a portal that shows all of the businesses that match the first 5 letters of this business here. There are a few, in fact, that are exact matches, just to give those as an example. So you can see the results from those. So I am going to run a little script that will send a REST request for all of these records, send REST requests for each of these records in a loop, and do fuzzy matching. So some of these, like for instance, this one here, had an LCS min of 10, which was above the minimum, was above the maximum match that I declared was considered a real match. So no match for that one. But here's one for which there were 2 records that are pretty good matches. They have LCS score 5, and Rangar West 4 LLC matches Rangar West 1 LLC and Rangar West 2 LLC. So these are businesses that are likely to be closely associated. But wait, there's more. You can run these things on your desktop. This works, but most people have their databases up on a server. And when you have large databases and are doing comparisons with a whole lot of potential hits, it will be much faster if you can do it on a server. So in order to put, of course, in order to put this file up on the server, you'll have to do manage security and create a full access account with a password, which I have already done. So let's see, let's close this and go to a server that I handily have running. Here is a AWS server that I have downloaded Node onto and installed it. And I've also installed a Postman agent here, but I skipped doing the VS Code because I've already done all of the development on the desktop, and really it's a piece of software I don't need to have running on this machine. This machine is, however, running FileMaker server. And we've got our sample file running here as well. So I'm going to demonstrate what you would do in order to put your microservice on a server. Here I have on the desktop, I have the zip file, and oops, no, that's not what I wanted to do. I want to extract all of the files in the zip file, and I'm going to put it on the local disk C:, and say extract. And now I have a folder microservice demo-main. In order to start up my web service, I am going to open a command prompt and run it as an administrator. Yes. Here we are at the command prompt, and we will change directory, cd space. We want to go to the directory that we've just created here. So, sorry. Up here. Right click, copy address. Here, paste. Now we're in our directory. We say, as we did on the desktop, npm install. Here we are. We've created this new node modules folder again. Taking a little bit of time. A little bit more time. There. Okay. npm start. Server running on port 3500. We go back to our browser. Here we are at the Postman. What is this thing called? This is the it is a browser-based Postman version. Here's our same request as we did previously. Localhost 3500 LCS. Server's running. Let's go back to FileMaker. On the desktop, we will open up our hosted file. Grab my password. Now I'm going to have to change my password. Okay, here we are. Now we can run our script as psauce. Fast. It works. Yeah, getting there, getting there. Okay, so now we have our microservice running on the server. We can use psauce or even use the script schedule on the server and do really fast fuzzy matching for all the businesses in the database. How are you going to manage to get this thing to be running all the time? Because while you can start this up and leave it running, there will come a day when you have to restart your server. And you might not remember that oh yeah, I got to start up the microservice. Okay, here's how you can deal with that. We'll do a Control-C here. Come on, stop. Control-C. I'm going to just kill this. Because it's a demo and it doesn't always work right. So, I think it was Vim de Court says that you should use a package manager to make sure that your load balancing is correct when you're running your microservice. It just seemed like it was far too much fuss to me when you can use the task scheduler to just make sure that your microservice is running. So in the files that you can download from GitHub, there is a little batch file. open the batch file. Oh, I should have left that command up. Command prompt, run as administrator. Yes. Okay, so what we had done previously was we did cd space yeah. Here we are. Copy address. Right? And then we did npm we did npm install, but that's something you need to do only the first time you run this. Then we did an npm start. So we basically copy this and go to the notepad and substitute in here whatever the path, the correct path is to where you've unzipped that file. And then it's the batch file will do this CD, then it will type npm start, and then echo off command /k will allow this to run in the background without having this command window open on your server. So we're going to save this batch file and go to here. I'm going to kill this now. Go to the task scheduler and create a basic task. And we can call it start microservice. And we say, start it when the computer starts, start a program, browse, start lcs.bat. Open the property dialog. Things you need to do. Run only when whether user is logged in or not. Trigger should be at system startup. Do that. Don't have to do anything here. In the settings, however, uncheck stop task if it's running longer than 3 days. You want this running all the time. And just in case, if the task fails, restart. Attempt 3 times. Ta-da. Now, run. It is now running. If we go here to our Postman, send a request. Yeah, it's working. It will run every time the system starts. That is what I have to say. And I hope you guys think it's nearly as cool as I do. And I'm going to stop sharing and ask if there are questions.
I have one quick question. What was the most difficult part, you think, in getting all that set up?
I did have trouble finding, there were several node package manager fuzzy matching algorithms that I tried to implement. And I have to say, I wasn't able to do it faster than I was able to find the code for just putting the calculation into the JavaScript. So that took a bit of flailing about. But I'm sure that had I persisted, I'd have been able to figure it out.
That was a very cool presentation. Very well done, Ena. Thank you.
Thank you. I'm really happy after having listened to so many presentations by generous people who've put time into showing people how to do things that I'm able to do it back.